In this video, we will be finishing up our discussion of section 4.7 over reduction of order with one last example. So since we are given this, and I deleted a lot of these directions, but given that this is a solution to this, we want to find another y sub 2 that is linearly independent to y sub 1 because we're guaranteed that, being that this dE is a second order or an nth order homogeneous. This side is equal to 0, right? Sorry, my pen's being funny. Hold on one sec. There we go. All right, given that this side here is 0. Okay, so we begin this method. Remember, since they are linearly, let's write this out, linearly independent, this tells us that y sub 2 is going to be expressed as some function u from function of x times y sub 1, where u is not constant. Right, so because if u was a constant, it would no longer be independent, it would be dependent. We are basing this whole method on that y sub 1 and y sub 2 are linearly independent solutions to this homogeneous ODE. Okay, so we take y sub 2, and we're going to find its derivative. So we get, first let's actually write down what it is with it plugged in, because we got u times y sub 1. I'm going to do u times, okay, that's t. So now we can find our derivatives. Y sub 2 of our first derivative, okay, that's going to be u prime times t plus u, right? Because t, the derivative of t is just a 1. We also need the second derivative. So that's going to be u double prime t plus u prime plus u prime. So we get u double prime t plus 2 u prime. Right, making sure everything's good. You want to double check, especially on this stuff. You don't want to do this whole problem. We're going to eventually hit problems that are extremely long. So get used to double checking your work constantly. I'm going to try to do it in the videos too, so we have the least amount of examples as possible. But double check your work as you're moving along too. Now I take the dE, and I'm going to plug in all this stuff. So t squared times, okay, we get u double prime t plus u plus 2u prime plus 2t, fill in y prime, so it's u prime t plus u, and then minus 2 times y, which was just ut, and this is equal to 0. All right, let's multiply everything out. We get u double prime t to the third plus 2u prime t squared plus 2u prime t squared plus 2u t minus 2ut equals 0. All right, let's highlight things that are going to go away. Those are gone. Is that it? I think so, and we can add those two together. So we got u double prime t to the third plus 2u prime. Let's go ahead and put the t squared first, and we get 4 of those now, right? 4t squared u prime equals 0. These are gone, right, to 0. All right, so I'm going to do one last step here. I'm going to get the u double prime by itself, which gets me 4 over t times u prime. And then the 0 on the right still remains 0. Now, we should be able to identify and remember that reduction of order will lead us to a first order linear ODE if we make the right substitution. So u prime, we're going to call w. So u double prime would be w prime. All right, so we get w prime plus 4 over t times w equals 0. This now is a first order linear ODE. So we solve from there. So since it's that, we need a mu. All right, so that's E2, okay, and we get this nice, easy integral that we like seeing because it makes things nice. We get e to the ln t to the fourth from that, right? Because we get a 4. I guess here, let me go step by step. 4 there. Then we get e to the ln of t to the fourth, which is t to the fourth. We always like the 4 over t's or constants over t's because that's how it ends up there, because we get that ln. Now I multiply everything by that. T to the fourth times w prime plus 4t to the third times w equals 0. Right? We do that because now that is a guaranteed product rule. I would always recommend, if it were me on a test, I would be double checking that if I do that product rule, that I get the line above. Right? That leads us to our integral to get rid of the derivative with respect to t. And then on the right side, we get 0. And be careful not to write 0 there. It is a constant. All right, we get t to the fourth times w. Right, remember we're using that w. We're going to do a back sub here in a moment. So we get c times t to the negative 4. Right, I'm going to leave the c. We could put a 1 if we wanted to. It's going to get absorbed anyway. And I'll show you what I mean. I'm going to leave it this time. Just to kind of, in case you don't trust that, like where are those c's going. Let's take a look at it. Okay, so I have w. W is u prime. That was from that sub earlier, right? C times t to the negative 4. So if I want u, then I have to take the integral. I can pull the c out front. T to the negative 4 dt. Okay, I run that integral. I get c times, okay, it's going to be negative 1 over 4 t to the negative, oh, no, I messed up. Okay, negative 1 over 3 t to the negative 3 plus c1, another constant. All right, this time I am going to choose that c1. We could do this either time. I'm only going to deal with one this time with that c. All right, so that tells me that y sub 2 is equal to whatever that's going to be. Okay, well, this becomes absorbed into a new constant, right? So this just becomes c, let's call it c2, times t to the negative 3. All right, that was u times y sub 1. So y sub 2, remember this was the u part, right? That is u. All right, u times y sub 1. Okay, so we get all that times, okay, c2 times t to the negative 3. And y sub 1, if we go back and look, was just t, which means y sub 2 is c sub 2 times t to the negative 2. Well, when I go to my general solution now, that constant made its way all the way to here, right? So we would have a new c, and I'm going to call this one c1 star, times t, that's y1, plus c2 star times c2 times t to the negative 2. And you can see that this is a new constant. So c1 star t plus, and then we could just call it, I don't know, do we have a c3? We'll call it a c3, t to the negative 2. Doesn't really matter. It's just a constant, a different constant than the one up front. They could be the same. They could be different. We don't know. They actually, I guess we could choose really, unless it became an IVP. Became an IVP, then we'd be restricted to find a C1 and a C1 star and a C3. I hope that made sense how the constants are absorbed. It gets a little tricky if we were to keep this in here, if you're wondering, because we'd have a plus. If we think about it, we'd have that 1 there, and then we'd have a plus 1 here with a constant, and then we'd have this other plus 1, and it gets really strange. So we're going to trust the intuitiveness of, if we just let those go away, we can find these other functions that do work. And if you're unsure, work it out all the way with your c's, and then just pick the c's to make the c's go away. You could do it that way too. I hope that makes sense on why those go away. I hope that you just don't trust it. What I would do is maybe work these problems out with the C staying. You can see it does get complicated pretty quick. So try that out. Like I said at the beginning of this video and throughout reduction of order, I don't really see too many examples of this often. Some of you guys, I'm going to say that, and then some of you guys are going to be in a special field, and I'm going to have like 10 of you guys come back and are like, hey, this was the only method from your class we ever used, or we didn't use any. With that, I want to end this video with, when you guys go off to your careers and your fields, know that I'm a mathematician. My degrees are completely in pure math. So I'm great at this stuff, and I understand how this stuff works. But the application side of where this goes with engineering after this, in your specific branch of engineering as well, there's all the sub careers of engineering, right? Subfields. Let me know. Come back, write me an email, right? Your class didn't teach me anything I used. These were the things that were more useful. Do more Laplace transformations. You're going to know what those are at the end of this course. Do more of these. We used these more often. We never once saw the series solution about a point, and you'll know exactly what I'm talking about when you finish the course on that point. So on that method. So please let me know in the future. You'll never offend me about any of that. I just need to know to get better. So, going with that.